Number 15, the Boom Overture is an innovative supersonic airliner designed to redefine the future of commercial aviation by combining cutting-edge technology with speed, efficiency. Number 14, the Nautilus Horizon represents a dramatic leap in aeronautical design and ambition, a vision of how commercial flight may evolve in the 2030s toward greater efficiency and sustainability. Its most striking trait is the blended wing-body architecture, which fuses wings and fuselage into a seamless lifting structure. This not only reduces aerodynamic drag but allows the entire aircraft body to contribute to lift, dramatically improving fuel economy. With that design, Horizon is poised to carry around 200 passengers over intercontinental ranges while burning roughly 30% less fuel and emitting far fewer greenhouse gases compared to conventional tube and wing jets. The internal volume of the cabin gains a remarkable boost, around 40% more capacity than equivalent narrow-body designs, which gives airlines flexibility to arrange seating, amenities, and layouts in novel ways. Inside, the Horizon will feature innovations like video conference pods to let business passengers stay productive, deluxe club seating for families to face each other in comfort, and ambient lighting systems that mimic natural light to reduce jet lag and create zones of calm. Because its engines are tucked toward the rear and integrated into the wing's upper surfaces, cabin noise is significantly reduced. Furthermore, the design is intended to be compatible with existing airport gates and infrastructure, sidestepping the need for radical overhaul of airports. All told, the Nautilus Horizon blends futuristic form with pragmatic advances to deliver a more comfortable, quieter, and eco-conscious flying experience that could redefine how we think of passenger aircraft in the decades ahead. Number 13, the Electra X Surf Air Mobility Partnership is building toward a new era in regional flight, with a hybrid electric eVTOL aircraft that promises to change where and how we fly. At its core is Electra's blown lift technology, which uses electric motors to blow air over wings and flaps, allowing the plane to take off and land in extremely short distances, as little as 150 feet, making it possible to operate from small airstrips, even non-traditional fields, roads, or campus sites. The aircraft will carry about 9 passengers plus baggage, powered by a hybrid system combining battery power and a small turbo generator that recharges in flight, reducing reliance on ground charging infrastructure and improving efficiency. Cruise speed is expected to be around 200 miles an hour, with a range of a few hundred miles on regular missions and reserve margin, enough for meaningful regional hops. Noise is also dramatically reduced compared to helicopters or conventional props, and emissions are lower thanks to the hybrid electric architecture. Surf Air Mobility brings its operational experience, its tech platform, SurfOS, and its aircraft-as-a-service leasing model to help scale this operation, aiming to integrate these aircraft into its network through subsidiary operators. The goal is not just about new planes, but about enabling direct aviation, bringing air travel closer to origins and destinations by opening up access beyond big airports, making flying more sustainable, agile, affordable, and accessible in places where traditional aircraft can't reach. Number 12. The Otto Phantom 3500 is a bold reimagining of the business jet, designed to push the boundaries of efficiency, comfort, and aesthetic audacity while forging a path for greener, smarter aviation. Its exterior is sculpted for laminar flow, with ultra-smooth surfaces and a carefully contoured fuselage that reduce aerodynamic drag to unprecedented levels, allowing it to cruise at transonic speeds while consuming significantly less fuel. In a striking departure from conventional jets, the Phantom 3500 dispenses entirely with windows. Instead, its cabin walls and ceiling are lined with high-definition digital displays fed by external cameras, creating an immersive virtual window experience that retains structural integrity and enhances aerodynamic performance. The cabin is generous in scale, with a stand-up ceiling height and a volume designed for 9 passengers, offering a sense of openness and flexibility absent from most jets in its class. Behind the scenes, the aircraft uses twin turbofan engines and next-generation avionics to control and optimize performance across a broad envelope, targeting up to 50,000 FT cruise altitudes and ranges in the several thousand-mile class. Its lightweight, composite-rich structure, low drag, and efficient propulsion allow it to slash fuel burn and emissions relative to existing business jets, further enhanced when flown on sustainable aviation fuels. All told, the Phantom 3500 blends radical design thinking with pragmatic engineering advances to offer a vision of private and corporate air travel that marries luxury, efficiency, and environmental ambition into one sleek, futuristic package. Number 11. The NASA X-59 is a path-breaking experimental aircraft developed under the Quest, quiet supersonic technology program, aimed at making supersonic flight over land acceptable by dramatically reducing the sonic boom into a gentle thump. Its design is striking. A long, slender fuselage with a sharply tapered nose that stretches forward to keep shockwaves from coalescing, while its wings and control surfaces are shaped and positioned to manage airflow and mitigate noise. The cockpit lacks a traditional forward window, instead relying on an advanced external vision system that streams imagery from high-resolution cameras to the pilot's displays, preserving aerodynamic smoothness while maintaining situational awareness. The engine is mounted atop the fuselage, which helps shield ground observers from direct noise and further softens acoustic impact. The aircraft is intended to cruise around Mach 1.4 at high altitudes, roughly 55,000 feet, so it can maintain true supersonic speeds while keeping the ground-level sound signature low. As a research vehicle, X-59 will fly over test corridors and populated zones to gather data on how people perceive the subdued sonic signature, information that will help regulators potentially lift bans on supersonic flight over land, and open the door to a future where fast, efficient, and quiet supersonic travel becomes a reality. Number 10. The Pipistrel. Nuva V300 is a groundbreaking hybrid electric unmanned cargo aircraft that blends vertical takeoff and landing capability with efficient fixed-wing cruise flight, offering a transformative solution for logistics across challenging terrains and remote sites. It features a tandem wing layout with multiple electric motors mounted on booms to provide vertical lift for takeoff and landing, then transitions seamlessly to forward propulsion using a dedicated rear combustion or hybrid engine pushing a pusher propeller, giving it both VTOL flexibility and efficient range. Its nose opens to allow direct loading of cargo. Number 9. The Volonaut air bike evokes the fantasy of flying like a hero in a sci-fi movie. Yet it's being engineered into reality as a one-person flying motorcycle powered by jet propulsion. It is designed with vertical takeoff and landing (VTOL) capability, eliminating the need for runways and enabling it to hover and maneuver in tight spaces. The vehicle's structure is extremely lightweight, built using advanced carbon fiber and 3D printed parts, making it many times lighter than a conventional motorcycle. Control is assisted by a flight computer and stabilization systems that make hovering, transitioning, and steady flight manageable even for users who are not expert aviators. In top trim, it is projected to reach speeds up to about 200 km/h, 124 mph, while carrying a pilot weighing up to roughly 95 kilos. Because it uses compact jet turbines rather than exposed propellers or rotors, it can navigate narrow corridors with reduced risk. Its flight duration is constrained, on the order of 10 minutes per sortie, but its refueling process is remarkably fast, taking under a minute. The pilot enjoys a 360-degree view and the visceral feeling of riding through the skies. Overall, the airbike offers an audacious fusion of motorcycle aesthetics and flight capability, a personal aerial ride that marries daring design with sophisticated control systems and lightweight engineering to deliver a truly futuristic form of transport. Number 8. The Alia 250 is an ambitious all-electric vertical takeoff and landing (eVTOL) aircraft developed to merge cargo, medical logistics, and regional passenger transport in a clean, efficient frame. It features 4 vertical lift propellers to enable quiet, precise hover and takeoff, and a single pusher propeller for efficient forward flight, giving it both vertical agility and fixed-wing range. With a graceful, arched-wing main structure stretching about 50 feet and a pronounced V-tail, the aircraft is designed for aerodynamic efficiency and stability at cruising speeds. Its cabin or cargo pod offers about 200 cubic feet of internal volume, enough to ferry critical goods, such as organs or medical supplies, or up to 5 passengers under a single pilot regime. The landing gear is a fixed quadricycle layout, supporting both vertical and transitional flight. Alia 250 aims to keep systems simple with fewer moving parts, allowing greater reliability and easier certification. Its batteries can recharge in under an hour, and its projected range on a full charge is roughly 250 miles, letting it bridge regional missions without fossil fuel use. Designers emphasize redundancy. Distributed electric propulsion ensures that if one motor fails, others can compensate, and each part of the aircraft is engineered for safety and maintainability. As such, the Alia 250 represents a compelling step toward the future of zero-emission, versatile short-haul air transport. Number 7. The Eve eVTOL is a vision of urban air mobility that blends elegance, safety, and practicality into one electric vertical takeoff and landing aircraft, designed to shift how people move in and around cities. It is built as a lift-plus cruise design, which means it uses dedicated vertical lift rotors for takeoff and landing, but once airborne, it switches over to fixed wings and rear propulsion to cruise. Avoiding moving parts shifting position in flight, the machine is fully electric, producing zero local emissions, and aims to keep sound down. Number 6. The Cavorite X7 is an audacious vision of hybrid electric vertical flight, designed to merge the agility of a helicopter with the speed, range, and efficiency of a fixed-wing airplane. Its most striking innovation is the patented fan-in-wing or H-over-wing system, a series of electric lift fans embedded into the wings and canards, which are exposed for vertical takeoffs and landings, and then concealed behind sliding panels when the aircraft transitions to winged cruise. In vertical mode, those fans provide thrust to rise nearly straight up, while in cruise, the fuselage relies on a pusher propeller driven by a hybrid gas-electric power plant. In this way, the X7 can fly like a regular airplane, with far lower drag once it's airborne. It is intended to carry 6 passengers plus a pilot, with a useful load of up to 680 kg in vertical mode, rising somewhat for conventional runway takeoff, and with performance targets of about 450 km/h cruise speed and a range near 800 km. The aerodynamic design is refined, including forward-swept wings for improved handling during transition phases, and the structure is largely composite to keep weight low. Safety and redundancy are deeply baked in. With its distributed electric propulsion, the X7 is designed to tolerate the failure of multiple fans in hover, and the hybrid architecture lets the gas engine recharge batteries mid-flight. The aircraft can also land conventionally if needed, and is being developed with robustness for all-weather operations, even aiming towards certification for icing conditions. Overall, the Cavorite X7 seeks to pull off a delicate balancing act, combining the vertical flexibility of rotorcraft with the energy efficiency and speed of airplanes to enable advanced regional air mobility in terrains and settings where neither helicopters nor jets alone are optimal. Number 5. The Joby S4 is a sleek next-generation eVTOL aircraft, crafted to bring urban air mobility into reality, seamlessly blending vertical lift capability with efficient forward flight. Designed to carry 1 pilot and 4 passengers, the S4 uses 6 electric motors mounted in tilt propeller nacelles. During takeoff and landing, those propellers vector downward for vertical thrust, then rotate to provide horizontal thrust during cruise. Number 4. The Lilium Jet is a striking example of where electric vertical takeoff and landing (eVTOL) aircraft are headed. A machine built for clean regional flights that combines elegance, innovation, and serious engineering in one airframe. It uses a network of dozens of small ducted electric fans mounted in tilting flaps, spread across both forward canard wings and rear main wings. These flaps swivel downwards to generate lift for vertical takeoffs and landings and rotate for efficient horizontal cruising, turning what would be inefficient hover time into smoother, more airplane-like flight when aloft. The aircraft is made from lightweight composite materials, keeping structural weight low while still delivering strength, and its fixed wings take over most of the lift during forward flight, meaning the electric motors only need to produce a fraction of their maximum thrust for cruising. This gives it a range of a couple of 100 kilometers and speeds in the high hundreds of kilometers per hour. The cabin is spacious for an eVTOL, designed to carry around 6 passengers plus pilot, with thoughtful layout to offer comfort and visibility. Windows are incorporated to help the sense of space. Its propulsion architecture gives redundancy. Because there are many small motors, the system can tolerate some failures without catastrophic loss of control. Flight control is managed by a fly-by-wire system that orchestrates fan speed. Number 3. The Otis Aviation VTOL concept is a bold leap toward redefining regional air travel and cargo movement, marrying the agility of vertical takeoff, landing with long-range, hybrid electric propulsion to serve both civilian and industrial needs. Its design departs from traditional tilt rotors by using a flap-based thrust vectoring architecture. Fixed electric propellers supply lift, and during hover or liftoff special flaps redirect thrust downward, then transition smoothly into forward cruise with wings taking over more of the work. The propulsion is hybrid electric. Batteries power the aircraft for shorter legs of roughly 200 miles with zero local emissions, while a turbine engine, capable of running on sustainable aviation fuel, takes over for longer missions, extending the total range to about 750 miles at speeds up to 345 mph. Inside, it's intended to carry 9 passengers plus 2 pilots in the transport class variant, with alternate versions tailored for cargo, medical logistics, or uncrewed missions. Because it can operate from vertiports, helipads, or conventional runways, Flexibility in where it can land and take off is built in, opening up routes that bypass large airports altogether. The flight control systems include advanced autonomy and software capable of remote or semi-autonomous operations, while redundancy, safety features, and modular payload capability ensure it can adapt to diverse missions from emergency medical delivery to regional passenger transport. Number 2. The SkyDrive SD-05 is an avant-garde eVTOL flying car concept built to bring urban air mobility into everyday life, blending compact design, electric propulsion, and computer-aided stability into a craft meant for short hops across city skylines. The aircraft is configured to seat a pilot and 2 passengers, and is propelled entirely by electric motors driving 12 small rotors mounted overhead on a boom structure, giving it robust distributed lift and redundancy so that loss of one rotor doesn't lead to catastrophe. Its carbon fiber composite fuselage is sculpted in an aerodynamic form, complete with wraparound panoramic windows that offer wide views while keeping surfaces smooth and drag low. In vertical mode, the multi-copter configuration handles takeoff and landing with agility, but once airborne, the lift burden shifts to aerodynamic surfaces, and the rotor's thrust vectors adjust, allowing forward cruising with efficiency. The SD-05's designers target a cruise speed of about 100 km/h and a practical range of roughly 10 to 15 km, with plans to extend that as battery technology advances, making it ideal for quick, last-mile or intra-city aerial links. Safety and stability are central. The flight control system is computer-assisted and includes redundancies and subsystems to manage rotor control, attitude, and transitions. With its quiet electric operation, minimal footprint, and ability to take off and land from compact vertiports or rooftops, the SkyDrive SD-05 aims to redefine how we move through congested urban corridors, turning what used to be long ground trips into minutes-long aerial commutes. Number 1. The Supernal SA-2 is a next-generation eVTOL air taxi designed to bring fast, sustainable, and quiet urban aviation into everyday transit, blending advanced electric propulsion with practical features shaped for the demands of city air mobility. With a design focused on efficiency and safety, the SA-2 uses multiple electric rotors for vertical lift and transition to fixed-wing cruise mode, reducing energy consumption once airborne. Its cabin accommodates 4 passengers plus a pilot, with emphasis on comfort, noise isolation, and legroom, making even short hops feel serene and premium. The aircraft's structure is built from high-strength composite materials for optimal weight and rigidity, while its flight control systems integrate full fly-by-wire architecture and real-time management of rotor thrust, tilt angles, and flight dynamics to ensure smooth transitions, precise hover, and responsive handling. Electric motors are redundantly distributed so that individual motor or rotor failure can be compensated by the rest of the array, enhancing safety in urban environments. Supernal is designing the SA-2 to match the constraints of existing urban infrastructure,